what do we need to do? Essentially, we already have developed all the core elements of the model. Okay? All the core elements of the model. In order to now add third dimensions, all you need to do is you need to refine all variables that you have, all arrays that you have, to be dependent on three components. Okay, you have a horizontal identifiers, which are called J and K. Have a look here on the little sketch, and you have a vertical grid pointer, which is called I. And now you have to look at the design of this, and this is the Arakawa C grid again, but now it's just adding the third dimension in the Y direction. Look here how this is done, where you define the V velocity. And you have to now do all loops, extending all the loops. Instead of double loops, you actually have triple loops. Okay, and all the solver, you know, the SOR iteration or so, that remains all the same. It's just adding one dimension, but the structure of the model remains exactly. However, you have problems now because it might take much longer to simulate. Simulations take much longer. If you just want to illustrate a simple process, like I've done before, it's not, you shouldn't use a fully three-dimensional model. So let's have a look at some of the things that you can. First thing, the geostrophic adjustment. And I showed you last part a geostrophic adjustment in 2.5 dimensions. Now we do it in 3 dimensions. And 3 dimensions means you have a box of fluid. Okay, you can use closed boundaries or cyclic boundaries, doesn't really matter here. And you over time introduce a circular region here where the density is a little bit lower, lighter water, and so. And you do that in a circular region, like a cylinder. And then you look at the adjustment, and now we can illustrate the adjustment by we can see the full surface velocity. This is shown here at the top. Here on the left, you can see that the flow actually run around in the end, this patch, and maintain this patch. So this is an eddy, and the flows run around this eddy, a geostrophic. I'll just show you the simulation. Simulation, it starts, see the Coriolis force, and again you get some pulsating features. These are inertial. So overall you get the currents running around. This is a top view. You look from the surface, from the top, you have a drone flying over this feature and take a picture from this. This simulates the so-called geostrophic processes. 3 dimensions. 3 dimensions.